Hello, we're going to talk a little bit about slope today, specifically slope of a line. I like to think about slope as the steepness and direction of a line. How steep is it? And what is the direction of this line? Slope is a line. It is consistent. It will repeat over and over and over and over and over again on the same line. The variable that we use for slope is m. Slope, often referred to as rise over run. And for me, that's pretty easy to remember because any time that I'm doing, well, not any time because I'm a teacher, so I stand up at the board, but most of the time that I'm doing math, other than explaining it, I'm sitting down. So if I were to want to go running, I'm not going to run too well from sitting in my chair, so I need to rise up first. And you being a student or sitting at a computer and doing this stuff, you probably need to rise before you can run to the bathroom or run to take a break or run to whatever it is that you do. It is a change in y over a change in x. And that also kind of makes sense to me because if I think of a coordinate plane and I think of my x and my y axis here, y, x, rise. Well, the one that's going up and down is the rise, and that is the y-axis. So the change in my y values will tell me how much it has risen. Okay, and then the opposite here. So this is x. There's my x-axis. That is my run. So, imagine a little guy or girl sitting here going, woo, hey, check me out, I can run. Whoa, there's my run, and he's running along the x-axis. I don't think he's going to be running up the wall unless he's like Spider-Man or something. So, mathematically, the formula for this, you will see y2 minus y1 over x2 minus x1. That is how we can plug in two different points to find our slope. That would be if we couldn't see it or we didn't have a graph, something of that nature. It is also commonly referred to as a rate of change. That should help you out in word problems. Miles per hour, meters per second, dollars per day. You see those rates of change where they're really comparing two different units. Most of the time that will be your slope right there. So we can kind of take a look at this in action here. So imagine that we had a coordinate plane, our axes here. Y and x, and we can randomly pick 2 points here. Could put a point there, and maybe I put a point there. We could find the slope if there were a line between those 2 points. So I should have a straight edge for that. Sorry about that, knocked it. So here we go. There I am. You can see me. That is a funny picture, but there we go. So if we had that going on, what we can do, in a very common way of finding slope, is to draw a triangle between these 2 points. So you can go up and over, or you could go over and up. It just needs to have a 90-degree angle in there. So let's say I drop down and over. There's my 90-degree angle. That's kind of what they refer to as a slope triangle. So first, you count your rise. 1, 2, 3, 4, 5, 6, 7. We have a rise. Then we count our run. 1, 2, 3, 4, 5. That right there has a slope of 7 over 5. And that is a positive direction slope. I look at this, and if you have seen my video on lines, I give you this little tidbit of information. If m is positive, your line moves in that direction, and I think of it with my 2 hands here. I am right-handed, as you can see, so for me, my right hand is my positive hand. If I put the right hand up, imagine me being that line, That would be the right hand, that would be the left hand, so the right hand is up. It is a positive line. If m is negative, well, imagine this pen, that's my right hand and that's my left hand. Well, hey, if I put the negative hand up, there you go, that is the direction of my line. You can also have this, and you can also have that. This line right here has a 0 slope. Look at the rise. It's not going up any. And then you could take a look at the run, let's say, from any two of these points. My rise is 0. My run would be 2. 0 over 2 is 0. That has a 0 slope. Opposite of that, you look at this line. Pick 2 points. Well, what is my rise? I'm going up 2. Well, what's my run, my side to side? 0. Anything with a denominator of 0 in math is what they refer to as undefined. There you go. So you have your 4 different lines with their 4 different slopes, the general direction of them. So when I look at this line, I'm thinking, oh yeah, my right hand is up. Okay, the positive hand is up. It's moving in that direction. The positive direction, it must be a positive slope. Look at a couple more here. Let's go there. And right there. And we're actually going to apply a little bit more about slope here. So coming through, you see that great picture. Need to find a better straight edge, right? Okay, that is a positive slope line. So if I will find my slope, I better make sure that my slope comes out being positive because it is moving in the positive direction, the right hand up. Okay, so I could come through, if these were the 2 points I were given, you could drop down, and then you could drop straight over. Make sure that you create a 90-degree angle right there, and you count your rise. 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1, 2, 3, 4, 5, 6. 9 over 6. Hopefully you recognize that those are both divisible by 3. Okay, so if I chop them down, 3 goes in there 3 times, 3 goes into 6 2 times. So my slope is actually positive 3/2. So what that means is I should be able to apply a slope of 3/2 to get my other points. So I could jump up 1, 2, 3 and over 2, and I do land on a nice lattice point right there. 3, 2. I could repeat that. 1, 2, 3 over 2, 3, 2. I could repeat that again. 1, 2, 3, 2. And I could repeat it again if I would like more points on this line. And we could do that till infinity. We could drop down 1, 2, 3 and over 2. See, it doesn't really matter the direction that I draw this triangle as long as I have that right angle. So there's another point. So we could continue on until infinity doing that. But as you can see, it does have a slope of 3 over 2. Well, now let's look at the coordinates of these points. 2, 3. The coordinates of this point, negative 1, 2, 3, 4. Negative 1, 2, 3, 4, 5, 6. Negative 4, negative 6. Okay, one of these will be the 1s and the other will be the 2s. It doesn't really matter. We're going to take the application of this. y2 minus y1 over x2 minus x1, and hopefully, if all works out well, we should come up with the same slope here. Okay, so it doesn't really matter if these are if this is x1, this needs to be y1. If this is x2, this needs to be y2. The ordering of these doesn't matter. What matters is that the 1s are with the 1s and the 2s are with the 2s. So it is y2 minus y1 over x2 minus x1. So I'm going to take, using parentheses, and I'm going to plug in to this equation, and I'll show the work right here so my hand doesn't cover it up. There you go. y2 minus y1 over x2 minus x1. And this really helps when you're dealing with the negatives here. So first of all, let's deal with y2, negative 6, minus y1. No. Okay, there we go, minus 3, over x2, x2, great, minus x1, there we go, 2. Now you clean that up and you do the math. Negative 6 minus 3, negative 9, over negative 4 minus 2, negative 6. Negative over a negative is a positive. And then we reduce it, and lo and behold, 3/2. That's a nice little application of slope. Thank you very much. I hope it helps you out. Have a nice day.